Hello everyone, welcome to the first module of Data Analysis with Python full course. This is Sumit Shukla, Senior Data Scientist and an educator. In this particular module, we'll be talking about how to perform data analysis with Pandas and some complex functions. So let's get started. So let's now start learning about some complex function in Pandas. Now I have already covered the basics of Python and the basics of Pandas in another video for which you can find out the link in the description box, and I would recommend all of you to complete those videos before you start this particular one, because here we will be talking about more complex functions. So let's get started. Now as you guys already know that if I want to use Pandas, I need to first of all import the Pandas library. So let's import Pandas as PD. So we have imported the Pandas library. Now in order to perform any kind of data analysis, we first of all need data, right? So let's import data. So pd dot read underscore csv, and I have already uploaded my data in this external repository known as data.word. So we'll be directly reading the data from this particular external repository. Now there is also a particular option to upload your data in this particular Google Colab, and then you can call that particular data into your data frame. That is one option which is always available. You can also mount your drive if you want to read your data directly from drive. But this option is something which I find convenient, but it is completely up to you which method you want to follow. So let's read this particular data and let's try to understand what this data is all about. So this data is having the details of various customers and their attribute that defines the customer. So we have customer ID, the gender of the customer, whether the customer is a senior citizen or not, whether the customer is having partner or not, and all other details. And then we have details like what is the contract, basically at what frequency the customer is paying the bill, so month to month, 1 year, 2 year. What are the various payment methods? So is it mailed check, or is it electronic check, or it is bank transfer? Then we have total charges, we have monthly charges, and finally we have the column churn. Now churn is equal to no means the customer is currently active in the network. Churn is equal to yes means the customer has left the company. So this is a very general English term. If I say that the employee has churned or the customer has churned, that basically means the customer has or the employee has left the company or left the service. So that is what the particular column churn in this particular data defines. Now the very first topic that we are going to understand is how to perform multi-level filter. So let's say I need to filter my data on one particular attribute, which is gender. So we will first of all take the gender column and then we will equate it to the particular value with which I want to filter. So is equal to, if you want to perform equality check, please remember we use double is equal to, and then we equate it to the category male. Now 1 is equal to basically means we are assigning, double is equal to basically means we are checking the equality. So wherever this gender column is equal to the male column, we will get the binary output, a series which is a binary series. So here you can see we have a binary series, and this is having true and false. The particular value true in this particular series defines that at index position number 1, the gender column is having the value male. Similarly, at index position number 4, the gender column is having the value female. But how to get the data? How to get the filtered data? So we will just simply say df square brackets. Now please remember these square brackets are used for indexing and slicing. So if I have to index my data, if I have to filter my data, if I have to slice my data, we use these square brackets. And then I will pass this particular condition in within this square bracket. So wherever I am having a false, I will not get that particular row. Wherever I'm having a true, that particular row will be returned to us. So if I run this, you can see that I do not have row number 0 in my output. Similarly, I do not have row number 4 because row number 4 is having false. So here also you can see we are having 3, but then we are having 6. We do not have 4 and 5 because those rows are having false. Now this is how you can perform single filter. But how to perform multiple filter, or how to perform filter on multiple conditions? Let's understand that with an example. So let's say I'm having one particular data which is having attributes like customer ID, gender, and let's say age. And then we have one more column, churn. Churn can have yes or no. Gender can have male or female, and age can be a numerical value within some range. Now, suppose that we have assigned the label or the variable to this particular data as df. So if I say df square bracket, then the first condition, df gender is equal to male. Then for and we use the ampersand, for or we use the pipe operator. So and df age is, let's say, greater than 18, then and df churn is equal to, let's say, yes. Now if we closely observe what kind of data we will get given this particular code and given this particular condition, we will get those customers who are male, their age is greater than 18, and they are churned. So churn is equal to yes. I'll get these customers. Now if you look into the general pattern of how we have written the code, we have the variable data frame, then we have these square brackets for indexing and slicing, and then within these square brackets I'm having condition 1, then and or, condition 2, then and or, condition 3, and so on. Now please remember, these conditions are needed to be separated by these round brackets. These are very important. So this is the general schema of how we write multi-filter in Pandas. Let's try to test it. So now let's say I have to filter my data on gender and on tenure and churn. So I have to write 3 conditions. So df, the very first condition in first round bracket, df gender is equal to male, and df tenure is, let's say, greater than 20 months. Then and the final condition, df churn is equal to no. Let's say this is my data. Now here you can see that I have got the filtered data. Now how to perform the analysis on this filtered data? Well, consider this as a new data frame. So consider this complete code as df. Let me go back to my slide. So what I mean to say is, if this is my code df condition 1 and condition 2 and condition 3, then consider this complete code as df. Now if I have to index any column from this filtered data, I'll just need to add a square bracket after this, which basically means if I add a square bracket after this, and let's say I have to extract the column monthly charges, then I can do simply like this. This is one way in which you can write the code in the single, or you can write the complete logic in the single line of code. That's one way. Another way is you can assign this output to a variable df or df1, and then you just do the same thing. So df1 square bracket, then monthly charges. Now please remember one thing, if I write the complete logic in one line of code, the advantage is we are not creating unnecessary variables, which is eventually going to eat up your memory, and it will be more cluttered, and it will be really difficult for you to manage all the variables. So I will always suggest you, until and unless you do not need an additional variable, don't create it, and try to write your complete logic within one line of code. Okay, so I hope you guys are clear with how to write multi-level filter. Now what we are going to do in this video as we move forward, we'll be looking at more and more complex mechanism or complex functions with which we can work in Pandas. One such technique which we have seen already is how to apply multi-filters. Now let's talk about a very important function known as unique and n-unique. That particular function is a very simple function but very useful in variety of cases. Let's try to understand the case and the function. Now let's say we have this data. Now given this data, I do not know, given a particular column, how many unique values or how many distinct values I'm having in a particular column. And sometimes you might need to get the idea regarding how many unique or distinct categories or values you have in a column, right? Maybe it may be for filter purpose, it may be for any objective, but you might have to get an idea about how many distinct values you have in a particular column, right? So let's say I need to find out what are the various distinct values I have in the column payment method. I'll just simply say df payment method, and then the particular function is this is not a function, this is known as the attribute, because it is the part of the Pandas framework. So the particular attribute is n-unique. Now it will return you the count, how many distinct values you have in the column payment method. We have 4, but what if I need to find out those values? What are those distinct values? I'll just use the attribute unique, and then the answer is we have electronic check, mailed check, bank transfer, credit card. Now what if I also need their count? What is the count, or how many rows I am having for electronic check, how many I'm having for mailed check, how many for bank transfer, how many for credit card? Then in that case we have a function, the attribute known as value counts. Very important, very useful. You do not have to apply group by, just say payment method dot value underscore counts, and here you have the answer. Now again, one more question. What if I want to look at the percentage? Now one way to get the percentage is divide this complete series by the total number of rows. How to get total number of rows? df dot shape, and shape is an attribute. So we have 7043 but I only need the number of rows, so we will index this tuple. This is my output as tuple. I'll index it, square bracket 0. So this is 7043. Now what I'll do, I'll take this code and I'll divide it with df.shape square bracket 0. That would give me the ratio, but I need a percentage. So I'll multiply this series with 100. Now if you want to avoid all these unnecessary steps, your value count function inherently comes with a particular parameter known as normalize. Normalize is equal to true, and we are done. Now if you want to avoid all these unnecessary functions and all these unnecessary code, your value count function comes with a very important or a very useful parameter known as normalize. Normalize is equal to true. This will basically return you the ratio. You can see we have the ratio, and if I simply multiply it with 100, I am done. I now have the percentage. Now you can see that these are very simple functions, unique and unique value counts, but they are very useful when you are performing data analysis, because when you perform data analysis, you sometimes needs to understand if there is a given column and it is having a lot of values, then what is the number of unique values you have in that column, right? And sometimes you also need to find out what is the proportion of each unique value in your column. So these functions comes very handy, right? So let's now try to understand about more complex functions. So let's now understand how to group the data. If I'm interested in grouping my data, let's say I'm having the data which looks like this. We have customer ID, we have the gender, we have, let's say, the tenure, and finally we have churn. And now we want to group the data on gender to find out average tenure. So group the data on gender to find the average tenure. Now this is what we have to do. So we will simply write df dot group by, on which column I need to group, on gender, then dot aggregate, on which column I need to aggregate, I need to aggregate on the tenure column, and then what aggregation function you want to apply. So I want to aggregate on the tenure column, and then what aggregation function you want to apply. So I want to apply the average, so I'll write mean, and this is my complete code. Now if you carefully observe, this code is having two subsections or two sections. Number one is, this is my target data frame, this is my group by command. So basically on which column you want to group, so on which column we want to group. Then once we have grouped the data, then how you want to aggregate the data. So grouping is done. Let's try to visualize it. So let's say I'm having some 4 rows. I'll just quickly create a dummy data just to help you understand the process. So 0, 1, 2, 3, gender is male, 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 female, and I should not write it in a grouped format. So gender is male, female, female, male. Then tenure is, let's say, 5, 10, 10, 5. And churn is no, 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 and yes. Let's say this is my data. Now we will have to group the data on gender column. So what will happen? I'll get the output like this. Gender will become the index of my data frame. So here I will have male, male, female, female. Then I'll have customer ID, which is 0312. Then I will have tenure. This will be 5, 5, 10, 10. And the final column is John. This will be no, yes, no, no. This is now the index of the data frame. Gender column has become the index of the data frame. This stage is known as the grouping stage, where I have applied the group by function. So here we have applied the group by function on the gender column. Now this is my data frame TF. Please remember that this is my intermediate output, which will not be displayed to you until and unless you aggregate. So this is my intermediate output, which is available in the internal memory but not visible to the user. So not visible to the user. Now it will only be visible to the user once you aggregate. So I will aggregate. Now, in which column I need to aggregate? I need to aggregate on the tenure column. Please remember, here you can carefully observe we have a dictionary. Here we have a dictionary. This dictionary is having the key as the column name on which you want to perform the aggregation. Then value is the function or the aggregation function. And this particular dictionary is a part of the aggregate function. So AGG is my aggregate function, right? So what will happen in the aggregation stage? I will get the output like this, where I'm having male, female, and against male I'm having average of tenure. So average of tenure will be 5 plus 5. This is 10 divided by 2, again 5, and this will be 10. And this will be my output, which will be visible to us, right? So this is how we group the data. Let's quickly look into one example. So df dot group by, I want to group on the gender column and then aggregate on the tenure column, and we want to use the average tenure. Here we have the result, right? You can see gender is male, female. We have the average tenure. How to perform multi-level grouping? What if I need to group the data on gender and the churn column? No problem. So in the group by function, instead of passing the column name, we pass the list of column names. So here we have a list, and then within that we pass the column name. The level 1 group is gender, level 2 group is churn, and then aggregate on. You can aggregate on any number of column you want. So first aggregation is on the tenure column, where I want mean. The second aggregate is on the customer ID column. The second aggregate is on the customer ID column where I have to count. So let's run this. Okay, I think the churn column has to have the capital C, so capital C, and then the customer ID column. So let me just quickly check. Small c and capital T. So small c and capital D. And here you can see we have the multi-level group result. So first we have grouped the data on gender, male and female. Then within female and male we have churn is equal to no and yes. Now if you carefully read this result, it becomes difficult for a reader or for a person who is analyzing or reading your result to better understand this, right? Now there can be multiple reasons, and there can be two schools of thought. Some of you may be thinking that this is the best result which you can read. Some of you may be facing a problem in reading this result. There is an option known as pivot table, which is very similar to the Excel pivot table, which can help you to perform aggregation on both rows and columns. As of now, using group by, we can only aggregate the data on we can only aggregate the data on row levels, not on the column level. Let's first of all look into the one group, which we will then convert into a pivot table. So let's say we are grouping it on let's say contract and churn, and then we are aggregating it on, let's say, the count, or let's say monthly charges. We are taking the average, so mean. Okay, we haven't closed the bracket over here, so let's close the bracket. Okay, something is still okay. There is one extra bracket. So here we have the result. We have contract group by level, we have the churn group by level, and then we have the average monthly charges. Again, difficult to read according to me. Let's try to transform it into a pivot table. So let's first of all understand the concept of pivot table. Now we have seen this result, right? We were having the two group columns and then one aggregation column. So how the result was visible to us? We were having the contract level, the churn level, and then this the average monthly charges. So contract was let's say month to month. Then we are having within month to month we have yes, no. Then we are having 2 year. So then we are still within this, I'm having yes and no. And then we finally have 1 year. Then we are having yes and no within it. And then we were having some values. So there was some value over here, 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 and here. But I want to transform this now into a matrix which looks like this. So on the row, I'm having yes and no, and on the column, I'm having month to month, 2 year, and finally 1 year. Let's say this is what I want to achieve. So let's say the values were A, B, C, D, E, F. Now the values are A, C, E, B, D, F. Let's say this is what I want to create. So using group by, we have created this output. So using group by, we can perform grouping on only row level. So we can only group the data on row level, but using pivot table, we can perform grouping on both rows and columns. So can group the data on both row and column level. So how we perform pivot table, or how to generate a pivot table? Number one, df dot pivot underscore table. This is the very first thing. Then we have to define what you want to keep on your index. So index, now index is nothing but this. These are known as my index, and as of now I have kept the churn column on my index. So I'll write, and on the index I want the column churn. This is known as my columns. So what I have kept on my columns? The contract column. So columns is equal to contract. Then using which column you have filled this table. So I have taken the average of monthly charges. So monthly charges is the column, or this is known as the values. So values, the values are monthly charges. And finally we have the attribute, which is aggregation function. So aggfunc, which is nothing but my mean, and we close the bracket. So pivot table takes 4 input. Number one, index. So what you want to keep on your rows, the row column. Then we have columns, what you want to keep on your column level. So column level. Then values, with which column we need to fill the table. And finally aggregation function, at or using what aggregation method you want to summarize the table. So function using which we summarize the table. This is what the pivot table function is. Now let's try to apply it in the data frame. So let's try to convert this row aggregated table into a pivot table. Df dot pivot underscore table. On the index I want to keep the column churn. Now there is no such limitation that you should only keep churn or you should only keep contract on the index level. It is up to you how you want your table to look like. If I keep contract, I will have 3 values on my row. If I keep churn, I will have 2 values on my row. So just to make sure I'm getting a rectangle which is horizontally visible, I'm keeping churn on my rows. So index is equal to churn, columns is equal to contract, then we have values is equal to monthly charges, and finally we have aggregation function. Aggregation function is, as of now, it is mean, and let's execute this one. Okay, there is some problem. Okay, I have used 2 is equal to. So here you can see we have the same result, but visible in a very clean matrix like pivot format, which is easy to read and easy to explain, right? So this is how we can group the data. We have seen both the examples, how to group the data on using group by functionalities, and within group by how to perform one level grouping or multi-level grouping. Then we have seen the example of how to use pivot tables to group the data on both row and column level. Now let's talk about how to delete a column and how to add a new column in a Pandas data frame. First, let's talk about how to delete a column. In order to delete a column, we have a function which is known as drop. And using drop, I can drop either a row or a column. So if I say df.drop, the drop function takes input as the name of the column or the index number of the row you want to drop. Let's say I want to drop the column as let's say customer ID, and I just have to write df.drop columns is equal to customer ID. Now please remember one thing. This particular function will return you a new data frame with that operation applied. What was the operation? To drop the customer ID column. So using drop function, it will return me a new data frame. So this is a particular new data frame in which this operation has been applied, but this operation is not applied to my core data frame or the parent data frame. So this df is still having customer ID column. If you want to get this operation applied permanently on the parent data frame also, then we have a particular parameter known as inPlace is equal to true. Now before you use this function, please remain very much sure that you want to drop this particular column from your data frame, because you cannot reverse back this operation. Once you drop a column, you cannot reverse this operation. You have to again go back, again import your data, and again perform all the operations that you have done. So please be very much cautioned before using inPlace is equal to true. I'm not going to use it as of now. I'm just leaving it as a commented code, but if you want to use it, you may use it. So I'll just copy this much portion, df.drop column is equal to customer ID. What if I want to drop a particular row? Well, in that case, I have the option known as df.drop index is equal to the index number of the row that you want to drop. So index will take the index number of the row that you want to drop. So I want to drop row number, let's say 2. So I'll just simply say drop 2, and it will drop row number 2. You will get a new data frame with that operation applied. So I'm having row number 0, I'm having row number 1, but I do not have row number 2. Directly have row number 3. Can we drop row and column simultaneously? Yes, you can. df.drop columns is equal to customer ID, then comma, index is equal to 2. And now this operation or this new data frame, you can see we do not have the customer ID column, I do not have the row number 2. So simultaneously we have dropped row and column. Now can I drop multiple columns? Yes, you can. So let me just quickly copy this. And in order to drop multiple columns, instead of just the column name, I'll provide list of column names. Let's say I also want to drop the column churn. And here if I scroll towards the end, you can see we do not have the churn column, and I do not have the first column, which was customer ID, right? So this is how you can drop the column. Now df.drop function comes with one more traditional way in which you can drop a row or a column or simultaneously both. Before the introduction of the parameters like columns and index, there was a parameter known as axis. So if you just want to drop a particular column, I can simply say df.drop the name of the column. Let's say I want to drop customer ID, and then I have to declare the drop function that this particular value, whether this value belongs to the column headers or the row index. Since it is a column, I would say axis is equal to 1, and then this will work as a function to drop a column. Here you can see we are able to drop a column. Now this axis parameter is really important. Axis is equal to 1 means I am doing something with my columns. Axis is equal to 0 means I am doing something with my rows. So if I just quickly copy this function, put it over here, instead of customer ID, if I write 2, and axis will now be becoming 0, then this will be working as a function to drop a row. And here you can see I do not have row number 2. So this is how we can drop a particular column or a particular row, or maybe both of them together. Now let's try to understand how to add a new column. In order to add a new column, so let's say this is my head of the data frame, and I want to create a new column which is half the tenure. So my new column df, the name of that new column is tenure underscore half, and this will have the value of tenure column but divided by 2. Now this is one way in which you can add a new column. If I quickly look, I will have a new column tenure half, right? So this is the general, you can say, code schema. The new column which we are assigning with this particular series, and this series is nothing but the half of my tenure column, right? Let's say I want to create a new column based on some existing column, and over the existing column I have applied some condition. So let's try to create that. First of all, in order to get some condition drafted, I need to quickly find out what is my minimum tenure and what is my maximum tenure. So my minimum tenure is 0, maximum tenure is 72. Now let's understand how to create the conditions. So first of all, we will create a function. Let's say function named as tenure underscore bucket, tenure underscore b. Then this function will have conditions like if let's say the input is a. If a is greater than 5, then I want to return, let's say I want to return the value as d. If the value is greater than or equal to 5 and the value is less than, let's say 20, then I want to return c. Then if the value is greater than or equal to 20 and value is less than, let's say 50, then return b. Then if a is greater than or equal to 50 and a is less than, let's say 60, then return, or let's say a is greater than or equal to 50 is my last condition, so I'll just simply say else return A. Now this is my function. If I want to create or if I want to apply this function to an existing column, I'll just say df the column name, which is tenure, dot apply this function tenure underscore b. Now it will generate a new series which will have values such as a, b, c, d. If I want to assign it to a new column, I can do something like this. So let's say tenure underscore or hyphen b, and this is my new column which is created based on a condition. Let's try to quickly apply this or maybe code this in Python. So let's first of all create the function def t underscore b. This function will take the input x. Now if my x is less than 5, then return let's say return d. Then elif x is greater than or equal to 5 and x is less than, let's say 20, then return, let's say c. Then elif x is greater than or equal to 20 and x is less than, let's say 50, or yes 50, then return b. Finally we write the else block, else return a. We have this function. Now we apply this function on the tenure column. So tenure dot apply, I want to apply the t underscore b function. We have the series. I want to assign this series to a new column which is df tenure underscore b, and here we have the new column tenure underscore b. Now there is one problem, and you guys would have learnt about this already, that when we create a defined function, it consumes memory, it gets preserved in our memory, and I do not need this function for next usage. I only need this function for one time. Once we have generated this new column, I do not need this. So the better way is to write the lambda function, right? So let's do it using lambda function. Tenure underscore b is equal to df tenure dot apply. Now lambda function is written with the keywords lambda, then input is x, then what output you need? I need d, I need the output d if x is less than 5, else I'll create another code block. I need the output c if x is greater than or equal to 5 and x is less than 20. Else I'll create another code block. I need the output to be b if x is greater than or equal to 20 and x is less than 50. Else I need a, and this is done. Let's not assign it to any variable. Let's only look at the output, and here you can see we have the same output. So it is always instructed or maybe suggested to all of you that if you are creating a new column based on certain condition on the existing column, always try to use the lambda function so that you are not wasting your memory. It is one time usage function. We have used it. Now this is not getting preserved anywhere in our memory, and we have also created this new series which I can preserve in a new column or existing column, and then we have that particular column in our data frame. Now this was all about this particular video. I hope we have covered up some good complex functions like how to apply single filter, multiple filter. Then we talked about the very small, very less known functions like unique, value count, and then how to use the parameter normalize in the value count function. Then we talked about how to use group by, within group by how to apply multiple level grouping. Then we talked about pivot tables, and then we talked about the drop function, how to use columns, how to use index, then how to use axes, and finally we learned about how to create a new column based on some conditions and the usage of lambda function. So whenever we paint something, we first of all need a particular canvas, or you may say you need a drawing sheet, right? So assume that this is my canvas, or maybe the drawing sheet. Now on top of this drawing sheet you can paint anything, right? So let's say I have created some good scenery. So here I have created some good scenery. So in total or overall, I can call this as a painting. Now a painting as an overall structure comes with two components. Number one, we have the canvas or the drawing sheet on which we essentially paint, and then we have the actual drawing or the scenery. So we have the drawing, right? Now why I'm talking about this is not a painting class, but this is the core concept behind how we visualize data in Python. Let's say I'm having the data like this. I'm having data with the customer IDs, then we have the gender, then we have the monthly charges. Now, if I want to visualize the count of males and female, we will essentially use a bar chart. So how that bar chart would look like? It would look like this, where on the x-axis I'll have gender, here on the y-axis I'll have count, and then we'll have male, female. So male, female. Now, in order to plot this, in Python we need a figure. So over the Jupyter Notebook, this plot is created over a virtual space which we call as a figure. So this is known as a figure. Again, if I connect this concept to the painting concept, this is nothing but my canvas or the drawing area, right? Now this plot is basically my drawing or the scenery which I am wanting to create. So this is my plot that is generated using the data, and if I connect this topic to the painting, this is basically my drawing. Now this is the core concept of how we visualize data in Python. We have a figure, and on top of the figure we create plots. On top of the figure we can create one plot or any number of plots you want, right? Now let's come to the topic of what is the requirement of the two libraries. We have Matplotlib and we have Seaborn. So if I have to perform data analysis, we have the library Pandas. If I have to perform scientific calculations or scientific analysis, we have the library NumPy. But why we have so many libraries, or essentially these two core libraries for data visualization? What is the requirement? Let's try to understand it. So let's say this is my plot and this is my figure. This is my figure. And on top of this figure, we have a plot. This is my sum bar chart. Now, if I want to do any kind of changement, if I want to tweak my figure, if I want to increase the size of the figure, and when I am saying figure, I am essentially talking about this canvas, the background virtual space on top of which I keep my plot. So assume that I'm having a A4 size sheet. Assume that this hand is a A4 size sheet, and on top of that we have created a drawing. So this is a virtual space in my Python, and then on top of that we create any kind of plot or any number of plots you want. So if you want to do any kind of change in the figure, let's say you want to increase the size of the figure, increase the size of the figure. So when I say increase the size of the figure, I'm basically talking about increasing the size of the virtual space where we have the plots. Let's say you want to add the grid lines in the virtual space. Grid lines. Let's say you want to add the title in the virtual space. So you have the plot over here. This is my plot. This is my plot. Let's say you want to add the title over here. Let's say you want to add the X label, Y label. So title, X label, Y label. Let's say you want to basically you want to change the color of the background. Background color. So like this, if you want to do anything with the figure, with the background, with the virtual space on which we have kept our plot, then we use the library known as Matplotlib. So the library Matplotlib basically helps us to control the attributes of the figure. Control the attributes of the figure. Now, Matplotlib library is not just limited to controlling the attributes of the figure. Using Matplotlib, we can also generate plots. Generate plots. So if you want to generate a bar chart, histogram, box plot, line chart, you can do all these things using Matplotlib. Now we will talk about why we need Seaborn. So let's talk about Seaborn. Now the library Seaborn is only limited to generating the plots using the data. So generate plots using the data. It can only generate plots. So if I'm having the task to do anything with the background, which is my figure, I cannot do that with Seaborn. If I have to generate a box plot, bar chart, histogram, line chart, maybe let's say maybe any kind of plot, then Seaborn is something which can help you. But if you have to do anything with the background, the figure, you have to use Matplotlib. Now you guys must be thinking that if Matplotlib is capable of controlling the figure attributes, as well as Matplotlib is capable of generating plots from the given data, then why we need Seaborn? What is the requirement of the Seaborn? Well, the requirement of the Seaborn is because of its great functionalities. Creating rich plots using Seaborn is very simple. So Seaborn generate plots which are very clean, and it also provides you so much functionalities such that you can change your plot. You can add more varieties to your plot using Seaborn. So creating a plot or generating a plot using Seaborn is much easier than Matplotlib. So using Seaborn, we get variety of functions and much better plots. And that is the reason whenever in Python we have the requirement to generate a plot, to plot my data, my first choice would be to use a Seaborn. And this is my personal choice. Whenever I have to plot anything, I essentially use the Seaborn library to plot something. But if my objective is to change anything in the background or change anything in the figure, then we use Matplotlib. So with Matplotlib, I use it for controlling the attributes of the figure. Now this is what your Matplotlib library is. So in short, or just to summarize, we use Matplotlib library as a core library to control the attributes of the figure. We use Seaborn as a core library to generate plots from the data. And as you can see that on top of the figure, you can keep any number of plots, right? So if my figure is controlled by Matplotlib, and if I'm generating my plots using the Seaborn library, then these two libraries can work together. There is no problem, because Matplotlib is working in behind to control your virtual working area, to control your virtual canvas. And on top of this, you can generate plot using any library. It can be Seaborn, it can be Plotly, it can be anything. Okay, so these are the two core libraries, and I hope you guys understood why we need these two libraries and what is the core objective of these two libraries. Now let's try to understand how to make use of them. Before we jump into the usage, let's quickly understand about the data. Well, you guys already know about it, but I'll just summarize. Well, the data consists of generally two kinds of variables. Number one is your categorical variables. Number two is your continuous variables. So categorical variables are basically your variables that consist of data as categories. For example, gender. For example, let's say city. Continuous variables are those variables which consist of data which is numerical in format. For example, income, total charges, and so on. So when it comes to the categorical data plotting, we essentially use two kinds of plot, and I'm talking about my personal choice or my personal experience in my whole data science journey, which is around 5+ years of experience now. I haven't used so many different kinds of plot, because the plots that I'm going to discuss today, or these are not many plots, 4 to 5 kind of plots. Your 4 to 5 kind of plot will help you to answer any kind of question which you will be getting in your entire data science journey. So when we have categorical data, I essentially use two kinds of plot. One is the bar chart. The second one is the count plot. When we have the continuous data, we have three kinds of plot. One is the histogram. One is the disk plot, which is used for plotting the distributions. And the third one is the box plot. And my personal favorite is box plot, because box plot essentially answers all your question and you even don't need the histogram and disk plot. So box plot is, I personally love plotting box plots. So we'll be looking at the example of all these things and how we can plot, let's say, two categorical variables and how we can plot two continuous variables. We'll talk about all of these. So let's directly jump to our Google Collaboratory. Now we have the data already available to us. So this is the data frame that we are going to use. This data is having the various attributes about the customers, defining the customers such as gender, senior citizen, partner, and so on, till we have the target column churn. So whether the customer has left the company or the customer is still an active customer. So we have been given with this particular data in which we have the various attributes defining the customer. We have the gender of the customer, senior citizen, partner, dependent, tenure of the customers in month, then what contract type the customer has followed. Then we have monthly charges, total charges, and finally we have the churn column, which defines whether the customer has left the company or the customer is an active customer. This is the data which we have. Now, let's start with continuous data plotting. Continuous data basically means the numerical data. So in the particular data which we are working right now, we have tenure, then monthly charges and total charges to be the continuous data. And let's try to start with the histogram. So we will first import the two libraries, import matplotlib.pyplot as plt, then import cborn as sns. And now, as I told you that we'll be using cborn for generating plots. So I'll just simply say sns.displot. Now dis stands for density. Those of you who are not clear with what density is, we already have a very detailed video on probability and statistics where I have talked about distributions, the random variables and distributions. So if you want to understand what density is, you can go and watch that particular video. That will clear all your doubts. What is the difference between probability and what is exactly density is. So here we are plotting a density plot, and then the column that we are interested in is, let's say, the tenure column, and my data is df. Okay, so this does not comes with a data attribute. Let's simply use the column name. Now here you can see that I'm getting a particular plot which is having the tenure histogram. The minimum tenure is 0, maximum is around 70, and we have these histograms defining the count of customers at various range. Now this is a histogram, but what if I want to create a density curve? Well, if you want to create a density curve, the only change that we have to do over here is assign the kind is equal to KDE. Now here you can see that histogram has been converted to a density plot. This is my density curve, where the y-axis is the density, x-axis is still tenure. Now what is the advantage of reading a density plot over a histogram? Here in the histogram you can see that I do not have a continuous curve, and looking at a density plot we have a continuous curve, and what we have to focus on is the peak. Now wherever I am having a peak, that basically means the proportion of customers at this point and at this point is higher. If I compare these two peaks, the proportion of customers in the entire data is highest over here, which basically means I am having highest number of customers in the lower tenure range, while there are good number of customers which are less than this in the higher tenure rate, and then in between I am having good number of customers. So you can see that in the left side also I'm having good number of customers, right side also I'm having good number of customers, in between I'm having less customers. So either we have less number of customers who are having average tenure or median tenure, but we are having high number of customers who are having low tenure, and also good number of customers who are having high tenure. If I am a data analyst working for this telecom company, I can just conclude that these customers are probably my new customers who are basically interested, or maybe who have joined the company in last 5 months or 1 month. That is the reason the proportion is highest in this particular range. Here these are my golden customers, or my precious customers, because they have been with the company for last more than 60 months, and these are my median customers. They are neither having very low tenure, not having very high tenure. They are just my median customers, and I would say these are my most stable customers. The reason we are calling them as a stable customer is because they have already completed a cutoff period around 10 months with the company, and they are proceeding towards becoming the precious customers, right? This is what inference we can derive from a density plot. Now, what if I want to change the size of this figure? Because as of now you can see that this figure is consuming a good amount of space in my Google Collaboratory. So if I want to change the figure size, we can either use Matplotlib, and I'll show you how we can use Matplotlib, but specifically for this plot we have the parameters, which is height. Let's say I want to keep the height as 2, and aspect ratio I want to keep it as, let's say, 2. Let's see what will happen. Now you can see that I'm getting a very small plot. If I change this aspect ratio, your plot size will change. You can see height is taking care of your height, and aspect ratio is basically taking care of the width. I want to keep it as 2 only, but this one we can keep it as 3, and I'll get a perfect plot, right? So this is how you can work with the disk plot. As I've told you that my favorite one is the box plot, and let's try to create a box plot for this. So sns dot box plot, and I want to create the box plot for tenure. Now here I'm getting the box plot, which is a vertical box plot. What if I want to keep the box to be as horizontal? Because we are much comfortable in reading the horizontal box plot, right? So only thing that you have to do is just say x is equal to df tenure, and you will get the horizontal box plot. Again, this box plot is not looking very nice because it is consuming a lot of space, and it is not properly fitting my screen, right? So the best thing that we can do is to resize it. Now this time I'll be using the Matplotlib library to resize this. Since I'm doing something with the Matplotlib library, I'll be using the PLT name, and then I'll be using the figure attribute. Now, since we are doing with the background, since we are changing the virtual background, the size of the virtual background, and as we have already learned, the virtual background is known as figure. So we are using figure. Then I want to change the figure size. So fig size is equal to, we have height comma width. So height I want to keep it 2, width let's say 3. So okay, width comma height is, it will be width comma height, so 3 comma 2. Maybe we can do it as 5 comma 2 will be a better, 5 comma 2 would be a better size. And you can see that we have the box plot. We have also adjusted the size of the box plot using the figure attribute and the figure size, where figure size takes width and the height, where width was 5 and height was 2. Now if I plot the same thing, so I'll just copy my code, put it over here. If I plot it for, let's say, the monthly charges, so now if I plot it for my monthly charges, you can see that the box plot is looking very similar, but this middle line is at different points. Now let's try to understand the interpretation behind how to read a box plot, because we know if I have to read a distribution curve, we have to focus on the peaks, but how to read a box plot? Let's try to quickly understand box plots. Now a box plot, so let's say this is my income and I'm having a box plot like this. Now, so this particular point represents Q1, this represents Q2, this represents Q3, and Q2 basically means the median line, while Q1 means the 25th percentile, and Q3 means 75th. Now if you already know how to read a box plot, you guys can skip this part, but those of you who do not know it, you guys can focus on this particular topic. So a box plot represents how your data is spread between a minimum value and a maximum value. This is my minimum value, and for this particular box, this is my maximum value, and the distribution is very normal. So if I create a distribution, it will look something like this. This is a normal distribution. Basically mean that in this median point, below this point, I am having 50% of the customers. Above this point, I'm having 50% of the customers. Below Q1, I'm having 25% customers. Above Q1, I'm having 75% customers. So if I want to create, or if I want to derive some inference out of this box plot, I would essentially say that we are having good amount of customers in the mid range, around 50%. So this box in the middle represents half of your customers. So 50% of the customers are in the middle of my data, which basically mean that most of the people are earning the average income. So looking at this plot, I will just derive or maybe conclude that most of the people earn average income. Now if I'm having a box, let's say like this, So a box like this. Now this box represents a right skew distribution. So if I plot a normal distribution, it will look something like this. So this is a right skew. Now what is the meaning of this? So this basically means majority of the customers are on the lower scale. So if I consider this x-axis to be income, most of the customers are earning low income, while these 2 points are nothing but your outliers. So box plot can essentially help you to identify the outliers, and this is my median. This is my median. So below this point I'm having 50% customers, and above this point I'm having 50% customers, but this box represents that most of the customers are on the lower side, where the box has been shifted towards the lower side of my x-axis. And similarly, I can have a box which is right skewed, the left skewed. So in that case, my box can look something like this, and I can have a curve like this. So this is my left skew, and I hope you guys now know how to read a box plot, right? So if we try to go back to the Python result that we have generated, so here we have the result. We can see that the median tenure is around 28. Almost half of my customers in the data are having a tenure of 10 to 55. So most of the customers are with the company for 10 to 55 months, where the median is 28. So below 28 I'm having 50% customers, above 28 I'm having 50% customers. Similarly, if I look into the box plot for monthly charges, the monthly charges for all the customers is around 70. But if I divide this, or maybe if I create a box plot for churn and non-churn customers individually, so let's filter this data for churn customers. So df churn is equal to yes. So these are my churn customers, and the box plot for churn customers. And for non-churn customers, how the box plot would look like. Now you can see that it is having a very clean pattern. The monthly charges for customers who have churned, who have left the company, the monthly charges, the median monthly charges is on the higher side, and you can see the box is towards the right, which basically means I'm having most of the customers on the right side, higher side of the monthly charges. While those who are not churned, you can see the box is shifted towards the left, most of the boxes towards the left, and the median monthly charges is around 63 or something, right? So basically a box plot can better help you to understand the pattern in the data. But here, since we are talking about how to plot, you guys can see there is one problem. If I want to compare the monthly charges for churn and non-churn customers, it would be great if I can put them side by side, right? So we have already understood that how to read a box plot, but right now you guys can see that since they are on two different cells, it is getting difficult for us to read it properly, right? So if I can put them side by side, it will be really useful and easy for anyone to compare. So let's see how we can plot multiple plots within one figure. Let's try to understand this topic. Now let's say This is our figure, nothing but the canvas. This is my figure. On top of this figure, I want to plot 4 plots. So one over here, let's say this is a bar chart. One over here, let's say this is a dist plot. Let's say this is a box plot. And last one is also a box plot. Let's say this is what my requirement is. Now, since I have to plot multiple plots on top of the figure, we'll be using the Matplotlib library to get this happen. Now, Matplotlib library comes with a function known as the subplot. So plt.subplot, this particular function takes 3 input. plt.subplot takes 3 input, a, b, c, where a is the number of rows in the matrix, b is the number of columns, and c is the index number or the plot number. So right now, if I consider this to be a matrix, then this matrix is of 2 cross 2 because it is having 2 rows and 2 columns, right? Also, I'll call this as plot number 1, plot number 2, plot number 3, and plot number 4. Always remember, your plot works or plot number are assigned in the zigzag direction. So I start from here, 1, then 2, maybe if I am having 3 plots, then 3, then 4, 5, 6, and again 7, 8, 9, and so on. We can keep on doing this thing like this, zigzag. So since we are having 4 plots, so 1, then 2, then 3, and then 4. Now we have to write plt.subplot, and we have to define the value of a and b and c. Subplot, a is going to be 2, b is going to be 2. Now the plot number is 1. Below this, I will write the code for plot 1, which is sns.barplot, or maybe whatsoever we want to plot. Then plt.subplot 2 row 2 column plot number 2. Below this, I'll write the code for the dist plot. So sns.distplot and the name of the column which I want to plot. Then the third plot, plt.subplot 2 row 2 column plot number 3. And below this, I'll write the code for the third plot. Similarly, plt.subplot 2 row 2 column plot number 4, and after this again I'll write the code for the last plot. So here you can see that in the code that I have written for plt.subplot, the parameter a and b are fixated because the matrix is defined that I'm having 2 rows and 2 columns. But the parameter plot number will change, and below each line of code I have to write the code to generate the plot. So assume that this is 1 bucket, 2nd bucket, 3rd bucket, 4th bucket, but you have to write all these code in one code cell. You cannot write them in different code cell. In one code cell you have to write the complete code, and then you will be able to generate all the plots in this matrix like structure. Let's look at one example. And right now the example that we are going to take is to plot 2 box plots side by side. So 1 box plot, then 2nd box plot. Now this is 1 row 2 column plot number 1, plot number 2. So 1 row 2 column plot number 1, then the code, 1 row 2 column plot number 2, then the code. And I'll write this complete code in one code cell. Let's do this. So plt dot subplot, one row, two column, plot number 1. Below this, I'll write the code for generating the plot. Then plt dot subplot, one row, two column, plot number 2, and then we will write the code for generating another box plot. Let's run this. And here you can see that we have two boxes in one figure, but the figure size is not looking that much nice. We have to adjust it. So we have the figure size parameter. Let's copy it and put it at the end in the top, because first we have to define the figure size and then only we can create the plot. So that is the reason the very first line of code, which should be the part of my cell, should be this figure component. So plt.figure fig size. Now I will make this as, let's say, 10, and so height can be still be 5, width can be 10, and height can be 2. Let's run it. And here you can see that we have two boxes side by side, but I do not know which box represents what. So for that we have to add the title. So we will add the title on top of each box. So plt dot title, and here the title is this is the churn monthly charges, and the below one is plt dot title, and this will be non-churn monthly charges. So now we can see that we have the title, we have the boxes, and everything is looking so nice. So this is how you can plot multiple subplots within a figure. But still there is one problem. The problem is they are on two different scales. How to plot them in one scale itself? Now for that, Seaborn is having one great function, sns.boxplot. Now on the x-axis, I will put the categorical column. X is equal to df.churn, and on the y-axis I will put the continuous column, which is monthly charges. Now just see what is going to happen. Now here we can see that in these two plots, I have specifically filtered the data for churn and non-churn. But when I have used x parameter as the categorical variable, so here my x is the categorical variable churn, which is yes and no, and y variable is the continuous variable, which is the monthly charges. The Seaborn box plot function has automatically created two individual boxes for each of the category. And now the advantage is that we have one y-axis for two categories. So it is now much easier to read this plot. Whereas previously we were having two individual boxes, but now we have one figure or one plot. Within that we have two boxes with the common scale, which make this plot easy to read. So you can compare the median monthly charges. The median monthly charges for those who are churn is higher than those who are non-churn. Similarly, the concentration of churn customer is higher on the higher side of the monthly charges, while concentration of people who are non-churn is on the lower side, right? So this is another advantage of using Seaborn. Now this is something which we cannot do in Matplotlib, and even if I try to do it, it will take a lot of extra line of code to get this happen. But you can see that just by writing x and y and using the boxplot function from Seaborn, we were able to generate such a nice clean box plot, and which is properly labeled also. Now, if I have defined the x-axis as the categorical variable, y as continuous, you can exchange this also. That would just make your, so let me call this as y and this as x. It will not change your plot, it will just change the orientation. So now you get the boxes which are horizontal, and your y-axis, which is the continuous variable, is on the x-axis now. So if you are comfortable reading plot like this, which is the vertical box plot or the horizontal box plot, you can choose to plot accordingly. So now let's talk about how to plot categorical variables. Now for categorical data plotting, as I have told you, we have two very popular charts, which is one is known as the bar chart, the another one is known as the count plot. Let's try to understand both with example. Now in order to plot a bar chart, we need to have one categorical axis and one continuous axis in such a way that each category is having one number against it. For example, if I'm having a data of let's say the average score of various subjects, so the subject name, average score, then another subject, average score, then another subject, average score. This kind of data can be plotted as a bar plot or a bar chart. Let's try to see one example. Let's say we have three subjects, A, B, and C, and we have the average scores as 100.2 and 89, and then let's say 88.3. Then if I plot a bar plot, so SNS dot bar plot, x is equal to capital X, y is equal to capital Y, and here we have the plot. You can see that almost all the three numbers are on the same range, so I'm getting 3 bars, which is very similar in the height, because one is 100, another one is 89, another one is 88, so approximately the same, right? So we have one category against which we have a one number, category number, category number. How we can do this when we are given with the data? Now remember in the last video, and if you guys haven't followed that, in advanced Pandas function, where we have learned about how to perform data analysis using Pandas, we have talked about a function known as value counts. And if you do not know about it, let's say this is my data and I want to know how many males and how many females we have in this column. So the very quick way of doing this thing is df.gender.value_counts, and we will get the category wise count of the category wise count. Now if I reset this, reset underscore index, I'll basically get a data frame where I'm having the name or the index column with the category and the gender column with the count. Let's try to plot it now. So I'll preserve this in a variable known as A, where A is my data frame. So I will write A is equal to this, and how my data frame A looks like. So A looks like this. So we will say SNS dot bar plot x is equal to A of index and y is equal to A of gender. Now here we have the bar plot. If you want to change the x label and y label, we can do that. So plt dot x label, I want to keep it as, let's say, the gender, and plt.ylabel, I want to keep it as, let's say, the count. And here we have the spelling is wrong. label. And here now you can see that the axis has been correctly named. Let's say I'm using group by command. So df.head, and against each category for, let's say, internet service, I'm finding out the average monthly charges. So df.group by internet service dot aggregate on monthly charges, and I want to find out the mean. So I'll get a data frame. Now this data frame is having index as internet service, monthly charges is basically my average. If I reset this also, then the index will become one of the column. So now we have internet service and we have monthly charges. Again, I will preserve it in a variable. Let's call that variable as b. Now how my b looks like? My b looks like a data frame. And now I can plot it. So SNS dot bar plot x is equal to b of internet service and y is equal to b of monthly charges. And if you want, you can rename the y-axis. So plt dot y label, and I want to keep the y label as, let's say, the average monthly charges. And here we have, okay, again spelling is wrong, label, and here we have the proper looking bar plot with various internet service and the average monthly charges against each internet service. Now this is how you can generate a bar plot. So let's say now your objective is to generate a count plot, which basically means against each category you just want to represent the count of that category with the bar. In that case, you do not have to specifically use the bar plot. You can simply use the count plot functionality. So let's learn how to do it. SNS dot count plot, and let's say I want to plot internet service. And here you can see we have the count plot. So we haven't aggregated the data. The count plot will do it internally for you. There is one very useful functionality that comes with count plot. Let's try to understand it. Now let's say I want to look at the count of DSL as the internet service, but within DSL, I want to understand how many customers are churn and non-churn. So within each category, I want a subcategory. That is something which you can add just by using the parameter u, HUEU. And I want u as churn. And just see the magic. Now within each category, you have a subcategory which is represented by the column churn. Now here you can see one thing which is very interesting. Here the count of customers who have churned is highest for fiber optics, which is represented by this orange bar. And the count of customers who have not churned is highest for DSL as the internet service. But these kinds of insight is difficult to find out in this plot, right? In this plot, I can only say that fiber optic is having highest number of customers, but the interesting point is that it is having highest number of churn customers. Now that is the usefulness of using U parameter. So U is nothing but adding a category on top of a category. That's how simple it is. So this was all about how to generate various plots in Python using Matplotlib and Seaborn. We have discussed about very limited number of plots, and the reason I have not taken you to multiple plots is because if my objective is to perform data analysis, these 4 plots are more than enough to derive any kind of insights, and we will apply these 4 plots in the next video to understand the pattern in YouTube data. Now first of all, let's understand when we try to browse any website, what are the series of operations happens between your web browser and the server of the website. So let's try to decode the complete process or the life cycle. So let's say this particular page, let's say this is your Chrome browser, and you can take any browser of your choice. Since I use Chrome a lot, so I'm using Chrome browser. And let's say this is your address bar. So here in the address bar, we have provided the address of let's say I want to browse wikipedia.com. So https://www.wikipedia.com. Let's say this is the address of the website that I want to browse. Now, as soon as you press enter, what will happen? Your browser will connect to the server of this website. So let's say this is the server of this particular website, wikipedia.com. But when your browser will be connecting, or when your browser will be reaching out to the server of this website, it has to carry some authentication information, right? It has to carry some information regarding your laptop, maybe the system, regarding your browser, and regarding your location. Because once the server will verify your detail, once the server is 100% confident that you are a legible user, you are not a robot, or maybe you are not trying to hack the system, then only it will allow you to browse the website. It will allow you to share the content of the website. So Chrome browser, when it is requesting the server, it will carry some authentication information. So here the browser is performing the request operation with some authentication information like your IP address, your location detail, your let's say browser detail. Now, once the server verifies all your details, so once the verification has been done, once the server is confident that you are a valid user, you are not trying to do anything suspicious, the server will return the HTML code of this particular website. The HTML code. Now, this particular browser, your browser on which you are trying to browse this website, this browser will render this HTML code in a form of a web page. So your browser will render the HTML code to a web page. And once you have the web page with you, once you have the HTML code with you, you can browse the website, and every time you make a click, the same process is happening. So let's say I clicked on a specific image. Again, a request will be made to the server. Server will process your request. It will return the HTML code, or maybe if you are looking for an image, it will return the image code, and that will be rendered by your web page to basically display you the image or display you the web page. Now when Python, so now we are not going to use a particular browser to make a request with the server. We are going to use Python to make the request. So we'll be having Python to make the request to the server, and then the server will return the HTML code using which, so using this HTML code, we will extract necessary information to get the data. So from this HTML code, we will get, or we will extract the data into the data frame. So from the HTML code, we will extract data into a data frame. This is what we are going to do. Now, in order to carry out this process, we need two libraries. In order to create a request, in order to send a request from Python to the server, we need a library known as request. So the library request will help Python to send a valid request to the server, and then server will return the HTML code. Now we need another library over here, which is known as beautiful soup. Now here this library will help you to perform search of the relevant content from the HTML code. So beautiful soup will help you to perform search regarding relevant content from the HTML code. So here we are going to utilize two core libraries, requests and beautiful soup. Now, before we can jump to the Python interface to actually carry out this operation, we need to briefly understand about how HTML code looks like. You have to understand the structure. So let's understand the structure of the basic HTML code. Now the HTML code, first of all, HTML stands for hypertext markup language. A particular HTML code starts with a tag, which is known as the HTML tag, and it ends with /HTML. So this is the starting and this is the ending, and within this we will write down the complete HTML code. Now the very first tag which you will find out within HTML is known as the head. Now head consists of the title of the web page. So whenever you try to browse any web page, let me just show you a quick example. So this is my browser. Let's say I want to browse wikipedia.com. So I'll go to Wikipedia. Now this is the title of the web page, wikipedia.org. This is the title of the web page. Now this is something which we are going to feed in the head tag. So head, here we have added the title, let's say, so wikipedia.org and then /head. Then we have the next tag known as the body. Now within that, we have to write down all the code that we want to appear as the body of the web page. So body tag starts with this tag body and /body will end this tag. Within this, I will have multiple tags. For example, h1 tag is for heading 1. Then we have to end this also. So let's add a heading. Let's add a heading. My first web page. Then /h1. Then we will have h2 heading, level 2 heading also. So welcome. Then /h2. Then we will have, let's say I need to write a paragraph, so p. Then we have written some paragraph /p. If I want to create a division, so what is a division? So let's say this is my web page, and within this I want to divide this web page into 3 divisions. So first section or division, second division, and third division. Now this is something which we can do using div tag. So div and then /div. Then for table, we have a table tag. So /table. Similarly, for hyperlink, we have href tag, and you will find out a variety of tags which are for a specific content that you want to put in the web page. But as of now, we are not talking about how to write HTML code. We are trying to unlearn and understand how to perform web scraping. So we will not be going into the depth of HTML code. But the reason I started talking about HTML code is to give you a brief idea regarding how the general schema or the general code structure of the HTML code looks like. So we start with HTML, we end with /HTML. Within that we have head tag, then we have body tag, and within body we have all the content of the web page. This is the HTML code. Now we have understood all the basics or all the basic knowledge that we need to perform web scraping in Python. So let's now start writing some line of codes to actually perform web scraping. Now let's start with scraping a web page. First of all, let's decide which web page we want to scrap. So let's go to wikipedia.com and let's search for height and weight data. So let's see if I can find out a table in this web page. Now we do not have any table in this web page. Let's try out for body mass index. So here you can see we have one table over here, another over here, another over here, another over here, and then over here. Here we have 2 tables. Let's try to scrape. Let's try to scrape some meaningful data. What about this? Okay. Let's try to scrape this particular table where I am having the region, population, average weight, overweight population, and the source. Let's try to scrape this table. First of all, we need the library known as request. Now, as I have told you, that request library will help you to send a legit request, a valid request from the Python programming language to the server of the website. Let's define the URL which we are trying to scrape. I'll just copy it, put it over here. And now we have to create a request. So the code is response is equal to request.get, then URL, the URL that I'm trying to get, comma, headers is equal to user hyphen agent. Now, what is user agent? Please remember, in the headers attribute, we have defined a dictionary which is having the key as user agent, and the value would be the browser's user agent. Now, to get your user agent, you have to just Google my user agent, and here you can see this is my user agent. I'll copy this and I will paste it over here. Now, what specifically is user agent? So as we have learned that while we are trying to request, while we are trying to send a connection request to the server, we are also sending, or the browser is also carrying some authentication information, like what is the IP address, the location, the browser details, and so on. Now the user agent is basically, you can say it's like a package or a coded information about all these details which are necessary for a server to know about your request, or about your location, your laptop, and your maybe browser detail. Everything is basically encoded in this user agent code. So that is what I have provided in this particular user agent. Let's try to run it. Now if I just type response, I am getting response 200. What is the meaning of this? So if I just Google what is response 200, so 200 represents OK in the HTTP, which is Hypertext Transfer Protocol, and this basically means that the request has been succeeded, which basically means the server has accepted our request and we have received back the HTML code. Now where we can see the HTML code? We have to write response dot, now there is a parameter known as text, and here we have the complete HTML code. But this HTML code as of now is in string format. You can see it starts with a inverted comma, ends with inverted comma. It's a complete HTML code in string format. If you want to check out this HTML code, just right click and click on inspect, and here you can see the complete HTML code. The HTML code. Now this is the HTML code which we have received over here as in string format. But the problem here is, if I have to search for the table, if I go back to this HTML, this web page, and use this inspect tool, and if I take my cursor to this table, you can see that the table is defined by the table tag with the class wiki table. You can see table, the tag name is table, class is wiki table, and within that I'm having all the rows and columns data, right? So my interest is to find the table tag from this complete HTML code. But right now, since my HTML code is in a string format, it will be really difficult for us to find out this specific tag from the complete HTML code. For this purpose, we have the beautiful soup library. So let's try to import it. So from BS4, import beautiful soup. So the function is capital B and capital S, beautiful soup. And now we are going to convert this HTML code into, we are going to convert this string into a HTML code which is searchable, on which we can perform easy search using the functions provided by this beautiful soup library. The name of the library is actually BS4, but it is so much popular in the market that everyone calls it as a beautiful soup library. So you guys can also call it as beautiful soup. Now let's try to parse this. Let's try to convert this string into HTML. So all we have to write is out is equal to beautiful soup response dot text, and we want to convert this into HTML dot parser. So basically I'm trying to convert this string, which is nothing but this response.text, into HTML parser, into HTML type of code, and this is done by the beautiful soup library. Now if I just print out, this is how it looks like. Now this is a proper looking code, a proper looking HTML code, right? But I'm not going to we are not going to manually check for everything from this HTML code. So we are going to use some inbuilt function that comes with this library. So let's try to perform the search. Now we are trying to search. So out.find, out is nothing but the HTML code that has been converted by the beautiful soup library. So out.find, we are interested in finding out the table tag, and the class of this table tag is wiki table. Now you can see that it will return you the HTML code of the first table, only the HTML code of the first table. You can see that the title is region, adult population, average weight, overweight percentage, and so on, which is basically this table, and this is the first table of my web page, right? First table. But what if I want to find out the HTML code for all the tables? Now this table is having this web page is having 3 tables. So this one is the first one, the second one, and this is the third one, which is empty right now. So in order to find all I have to do is use the find all function. Now we get a list, and this list will have comma separated HTML code for all the 3 tables. So it is quite huge. That is the reason it is quite difficult to understand, but let me try to help you to visualize it. So basically, when we use find all, we get output as a list. Now since I'm having 3 tables, the first element in this list will be the HTML code for table number 1, comma. The second element would be the HTML code for table number 2, comma. The third would be the HTML code for table number 3. This is what find all will return us. Now if you're interested in, so let's say this list is L. If I'm interested in this table, all I have to do is L of 1, and this will return me the HTML code for table number 2. If I say L of -1, this will return me the HTML code for table number 3, right? So this is what the output is returned when we use find all. Now here, let's quickly preserve this output in the list L. And from this list, I will extract the code for the first table. So L of 0. This is the HTML code of the first table. Now how we convert this particular HTML code into a data frame? For that, we will use the Pandas library. So now this is the code of the first table. Since we have used find all, we have the HTML code for all the tables with the class wiki table in a list. And now I'm interested in the first table. So we have extracted the HTML code of the first table, and this is my HTML code of the first table. Now we are going to convert this HTML code into a Pandas data frame. For this, we will use the Pandas library pd.read_html. Now this particular function needs the input as a string, but right now the HTML code that we are having over here is a beautiful soup object. So if I have to convert it into a string, all I will do is to just wrap it in the string function, and this is my string now, right? So here I'll provide the input as str of L of 0. Now again, this particular output is within a list. So if I preserve it into a variable a, then a is a list. And if I index, so a is having only one element. So the list a is having only one element, which is a data frame. So if I just index it, L of 0, I'll get the Pandas data frame. This is my Pandas data frame, right? So let's preserve this into the variable df. And df.head is the data which we were trying to extract. Now we have seen the complete process of how to extract the relevant data from a particular website. But still, this particular data is not something which we will be able to analyze easily. So we will be required to do a quite of manipulations on this. Let's try to manipulate this data. Let's try to clean this data. This is specifically known as data cleaning. First of all, we will check the data types of various variables. So df.info. Now the particular column adult population million is an integer 64, which is okay. I will not say this is correct, but this is okay. Region is an object, which is again fine. But average weight should have 60.7 in one column and 113.8 in another column, so that I have both the quantities but in two different columns. Then overhead population divided by total population. I need this in let's say I need this in float format 28.9. I do not need this percentage. Due to this percentage, the column has been loaded as object. And I do not need this source column, so I will drop this source column. Let's do this. First of all, df.drop columns is equal to source, and I will do this in place because I'm 100% sure that I do not need this column. Now my data frame is having four columns: region, adult population, average weight, overweight divided by total population. Now here we have extracted the table from the Wikipedia page, but this particular table or the data frame is still not perfect or in the clean format to perform data analysis, because number one, you can see that there is a percentage sign over here, due to which this column is not in the float format, in the decimal format. In Pandas, we call this as a float format. So right now this column, which is overweight population divided by total population, is not in float format. Similarly, average weight column is having two numbers and the complete detail is in one column. Again, this column is not in float format, it is in object. So right now what we are going to do, we are going to clean this data frame in such a way that it becomes more useful, and for any person who is trying to perform data analysis on top of it, it becomes really easy for that person to perform the visualization, perform any kind of analysis. So let's try to do it. As of now, if I look at the info about this particular data, we have region and adult population millions. These two columns are in correct data type, while these two columns are needed to be corrected. Now let's try to extract the 60.7 in another column, which represents the average weight in kg, 113.8 in another column, which represents average weight in lbs. Let's do that. Now, in order to do this, we will be required to use a particular library known as regular expressions. Now, if you do not know about it, it is very simple. It is a pattern matching library. We'll try to understand it step by step. I will only take the first entry in a string known as A, so that I can show you all the operation. Now, the very first thing that we will do is to split this on this particular opening round bracket. So A dot is split on the opening round bracket. We will get 60.7 kg in one particular, so this is the first element of my list and this is the second element. Now from this first element, so if I index it at index number 0, I'll get the first element. I want to extract 60.7. For this I will use the RE library import RE, which is regular expression, and I'll say find all, which is RE dot find all. I have to define my pattern. So I have to find all the digits. So /d plus /d means I want to find out all the digits, plus means one or more time. Then /dot. I want to find a dot. So my pattern is digit followed by a dot, then a digit. So digit one or more time followed by a dot, and then again a digit one or more time. This is what I am interested in finding out from this particular string. So what output I'll get? I'll get 60.7. But this is in, again, is this particular thing is in a list, so I have to index it again. And now I have to convert it into float. So I will encapsulate this complete code into the function float. Now this is what we are interested in, and this is what we are going to do for all the rows. Now in order to do it all the rows, we'll be using the apply mechanism, and we'll be writing the lambda function. So we'll write the complete logic in lambda function. So let's do this. df average weight dot apply lambda x colon. Now x basically mean x is going to be this. So I'll copy this complete code, and instead of a, I'll just put x, and this should work fine. We have all the responses, right? I'll preserve this output in a variable which I'll call as df average weight in kg. And now let's preserve this output. So now if I look at df.head, we have average weight in kg, and here you can see we have average weight in kg, and this is in right now float format. Similarly, I'll try to extract 133.8, and I'll create a new column average weight LBS. Now in this above code, all I have to make a change is when I'm splitting, instead of extracting the first element, I'll extract the second element, which is a square bracket 1. This one, right? So all it is going to change is over here and over here. So let me just copy this, put it over here. I'll replace the 0 with 1 and this kg with LBS. And now df.head will have 5 columns. So we have extracted both the quantities in 2 different columns. Now I can drop this average weight column. So let's drop it. df.drop columns is equal to, I'm interested in dropping this column average weight, and let's do this in place. In place is equal to true. df.head. Now we are done with one task. We are now left with this task. Again, we have to extract only the numerical portion of this particular string. So first of all, let's do one thing. Let's rename this column. This column is having a very lengthy name. So df.rename columns is equal to. Now instead of copying the column name from here, we will copy it after calling df.columns, because there might be some extra spaces. So I'll copy it from here, put it over here, and I want to rename it as weight over weight percentage, and I will do it in place. Now we can see that now the particular column headers looks clean. Even we can do the change with this also. We can replace this millions with capital M. So let's copy this code, and instead of adult populations millions, we can have the same column name but with capital M. Now how my DF looks like? Now my DF looks like way better than before, right? The last thing that we are left with is to get rid of this percentage sign. Now we will do the same thing what we have done previously for extracting the numerical component from the average weight column. Let me just quickly show you how we will do it. So df over weight, I'll take the first value just to help you with the operation. It's a string. Now we will use the same operation, like the same mechanism that we have used using find all mechanism. So let me copy it, put it over here, and the string is A. So we have 28.9. This is a list, so we have to extract it. This is in a string, so I have to convert it into float. And this is the final code that we are going to use in the apply function. So let's do this. Over weight dot apply lambda x colon. Now instead of, so we will put this, but instead of A, we will have X. We have all the entries in float now. We will preserve this output in the same column. And now if I look at df.head, now you can see that the data is very much clean, and now we can perform any kind of data analysis. So let's say I wanted to create a bar plot for region and average weight in kg. So sns dot bar plot, and the x-axis we will keep the region name, and the y-axis we will keep this particular column, which is average weight in kg, and let's run it. So here we have the response. Now here you can see that we are not able to look at the X labels. We can rotate them, and we'll be using Matplotlib .xtext rotation is equal to, let's say, 45 degree. And now you can see that all the labels are clearly visible, but I really don't know why we do not have the label for this one. Okay, we are only looking at the head. Let's look at the complete data. So we are here having 1, 2, 3, 4, 7 entries. 1, 2, 3, 4, 5, 6, 7. Okay, so these two are getting overlapped. This should be over here, but it is coming on this side. Now the problem is, since we are using 45 degree rotation, the x-tick for this particular bar is shifting towards the next bar. The very simple solution for this is, let's make the x-ticks to 90 degree, which is like perpendicular. And now you can see that we are able to get all the x-ticks properly, and the plots look very nice, right? So before we directly jump into the YouTube data analysis, we will first of all understand some basics by taking one dummy data. So let's import Pandas. because as you guys already know that for any kind of data manipulation task, we need the Pandas library. So let's read in the data. And as you guys already know that for importing the data, we need the particular command pd.read_csv. And here I have uploaded my data in a particular repository known as data.word, and I am utilizing the link from that platform to read in my data in the data frame named df. So let's import my data, and let's now look at the head of this data frame. Now this data is about various games that were released in past, let's say past 20 years. We have the name of the game. So we have WII Sports, Super Mario Bros. We have the platform in which it was released, in which year it was released, what was the genre, who was the publisher, and then we have the parameters like the North America sale, the Europe sale, the Japan sale, other sales, global sales, and then we have the score. So critic score, critic count, user score, user count, the who was the developer, and rating. This is the data which we have. Now, the very first thing that we will be trying to understand is how to clean the data. As you guys can see that there are some errors that you guys can easily find out in this data. Number one is years of release. Now, as you know that right now this column is in float data type. You can see a .0 which is decimal point. Then here also 1985.0. Now a particular year as a column, as a feature, is considered as a categorical variable, which basically means I am considering each year as a category. So I will have some games getting released in 2006, some games getting released in 1985. So each year is considered as a category. But Pandas has loaded this particular feature or the column as float. So we have to correct it so that when we are trying to perform any kind of data analysis, we are not considering it as a float column, but as an integer column, or the best would be to consider it as an object column. Oh, but there is one more thing that you guys can use to understand whether to keep a column as an object column or a float column or a integer column. So if your objective is to perform any kind of mathematical process on a particular column, then better to keep it as float or integer. For example, are we going to add these 2 years? So 2006 plus 1985? No, because the addition would not make any sense. Are we going to subtract it? Maybe subtracting would make a sense, but here my objective is not to subtract. I'm not going to multiply. I'm not going to do any kind of mathematical operation on this particular column. And hence, we should keep this column as object because that best suits our current objective for the data analysis in this particular data. So let's try to understand how we can convert this column. Right now it is in float, how we can convert this column from float data type to either integer or object. Let's do that. So we have df. I'll just quickly copy the column name from here, years of experience. And if I look at the D type of this column, which will eventually return me the data type of this column, it is float 64, right? But my objective is to convert it into integer or object. So first, let's try to convert it into integer. Now, Python provides us with a particular functionality known as type. So let's utilize it. Here is my column dot as type, and I want to convert it into integer. So I'll write int, integer. Now here we are getting error. The error says cannot convert non-finite values na or infinite to integer. You guys can, this is a problem that is something you can find out while working with the data and while performing data analysis. You're trying to convert a column which is float into integer, but you are getting error that a particular column, for example, this particular column years of experience is having some NA, which is not available values or infinite values, which cannot be converted into integer. Now, are we having any kind of nulls in this column? Let's try to quickly check. So, how we can check it out? Dot is null. So, it will return me a Boolean series, which will have true and false. And in order to find out how many trues we have, how many ones we have, we'll just take a sum of this series. So dot sum. And this column is having 269 nulls. Now, what is the solution to this problem? Should I replace these nulls in order to convert it into integer, or should I directly convert it into object? If I directly convert this column into object, then instead of float, I'll get the exact same value in object. If it is not making sense, let me quickly show you. So right now, my column is, let's say 2006.0. This is a float value. If I convert this into object, it will become like this, 2006.0. And why these inverted commas? Because now I have converted this into object, which essentially or eventually means I have converted it into a string. So converting a particular float value into a object column will not make any sense, because it will not solve our problem. My objective is to convert this column into something like this, 2006, without any decimal points. Now, how we can do this? There is one data type known as the nullable integer data type. Nullable, let me write it down. It is nullable integer data type. What is the meaning of this? Let's try to quickly learn about it. What exactly nullable integer data type is? So let's Google it. Nullable integer in Python. And let's try to read this document. So in working with missing data, we saw that Pandas primarily use NaN to represent a missing data. Because NaN is a float, this forces an array of integers with any missing value to become floating points. If you are listening to me very carefully, you guys would have already understood the problem. So what happens? Pandas use NaN to represent a missing value in a particular column, right? Now, since NaN is a float data type, this forces the complete column to be typecasted to a float column or a float data type column. So if any numerical column is having missing value, then it would be loaded as NaN. This is the default structure or default working of Pandas library. Now, how to convert it into integer? So in order to solve this problem, Pandas came up with a new data type known as the nullable data type, nullable integer data type, and it is represented as capital INT64. So here it is written, note that the capital I to differentiate from NumPy INT64. So it is capital INT64 with it is INT64 with capital I. Let's try to utilize this. So instead of INT, we will use capital INT64. And now you can see that I'm able to convert this column into integer. let's try to preserve it back to the same column. I'm trying to preserve this output into the same column so that now years of release is having only integer values. So let's do that. And now let's try to calculate the number of nulls. So now I'll copy this column, copy this code, put it over here and run it again. Again, we are having 269 nulls, but it is now this column is an integer column. So that is what the advantage of using this nullable integer data type is. Now using the same logic, we can typecast all the columns which has been incorrectly loaded as float into integer. For example, all these columns which are critic count and user count. Now since they are count, that basically means they need to be in integer. So we should be converting them into nullable integer data type. Let's do that. So I'll get all the column names, df.columns, and I will perform the same operation. So for critic count, I'll use the same logic, critic count dot as type capital int 64, and I'll do this for user count. I have done a mistake. I should be selecting critic count, not the critic score. So let's do that. And now we can execute both of them together. So if I look back the data, the head of the data, you will find out that now we are having NA represented in these special brackets, but this column is now in integer. You can see all the values are integer now. Previously they were in float, right? So this is the advantage of using nullable integer data type. Let's quickly understand one example of how to convert integer into object. So let's say now I want to convert year of release, that is right now a particular integer column. So right now this is integer data type. If I want to convert it into object, I'll just say as type, and for object you can use either capital O, or you can write simply object, or you can write str. Anything is fine. So I'll use object, and now you can see that the data type is object. Let me preserve it back to the same column, and we are done. Now let's perform a quick count, and you guys already know how to create a count chart. We can use the count plot from Seaborn library. So let's do that. Import Seaborn as SNS, import Matplotlib.pyplot as PLT. Now let's plot SNS.countPlot, and we are interested in plotting years of release. And here we go. Let's execute this. Okay. So float argument must be string or a real number, not any data type. Now the reason we are not able to plot it is because this column is having nulls, and Seaborn is not able to recognize any data type. So what we will do, we will drop only those values. So dot drop NA, and let's execute it. And here we have, so right now you can see that there is some problem. I'm not getting the plot that I want to basically have. Basically I'm interested in getting a plot where I'm having in the x-axis I have year of release, and on the y-axis I'm having the count. So the problem is I haven't written x over here. And here we have the plot which we are interested in. How to remove this particular overlapping, we have already learnt about it. We will just rotate the x-text. So plt dot x-text rotation is equal to 90 degree. And here we have the plot. So now you can see it is very clean, and these two are the years, which is 2008 and 2009, in which highest number of games were released, right? So this is how you can tackle the problem of data type conversion, also known as typecasting. We will see one more example in which we'll be using a special function to get this done. So right now we have used the function as type. Let's talk about one more function which is really useful to perform the typecasting from object to any numerical column. Let's talk about that also. So let's now utilize one more sample data, and let's talk about a very special function known as pd.toNumeric. So here I have already uploaded one file known as telecomchurn.xlsx. I'll copy the path and load it. So df is equal to pd.read_excel, and we will paste the path. Let's look at the head of the data. So here we have this particular data. Now if you guys closely observe, here in this data we have tenure as one of the numerical column. Then we have monthly charges, total charges. If I look at the data type of all the columns, D types, in that case, senior citizen is an integer data type, which is wrong because it is a binary column, which basically means 0 means no, 1 means yes. So we will replace these values with no and yes, because everything is no and yes. The second is tenure, which is an integer, that is correct. The third one is monthly charges, which is in float, that is also correct. Total charges is an object, and this is wrong. So let's first of all tackle this problem, senior citizen. So what we will do, df senior citizen dot replace, I'll replace my value 0 with no and 1 with yes, and I'll do this in place is equal to true. So now let's look at the column senior citizen, and here you can see that we have no and yes. So we are done, right? Previously it was all zeros, basically means 0 means no, 1 means yes. Now we have no and yes. The second problem is with this total charges column. So the first of all, let's try to understand why total charges has been loaded as object. So df total charges, and we will try to convert this into, let's say, float. Let's see what happens. So here it says could not convert a string to float, and this is what it is not able to convert. What this known as? This is known as a white space. What is a white space? White space is nothing but a empty string. For example, this is a string which is having some characters. So here each term or here each alphabet is a character, right? But I can have a string like this also, right? Now this does not have any character, so no character. So this is known as a empty string. Empty string, also known as a white space. White space. So this is the problem that this particular column is having. In the total charges column, it is having white spaces. Now how we can deal with this? There are two solutions to deal with this problem. Number one is First of all, I replace all these white spaces into the Pandas recognized nan, which is np.nan. The second solution is use pd.to_numeric with the error attribute. Now, what is the meaning of this? Let's try to understand this. We will be using the second approach where I'm going to use pd.toNumeric with the error attribute. Let's try to understand this. This is how we do it. pd.to_numeric. I want to convert this column into, and let's run it. So pd.toNumeric, this particular function automatically converts a particular object column into the numerical column. Now, when I say it converts into numerical, based on the content of the column, it will identify whether to make the conversion as float or integer. For example, right now, if I look into the total charges column, since the content of this column or the values of this column is in float, so this function pd.toNumeric will automatically identify that the conversion has to be made into float. But right now we are getting error. It says unable to parse the white space. It is not able to convert the white space into either integer or float. How to do this? So this particular function comes with a particular parameter or attribute known as error. Before we use it, let's quickly read the documentation of this. So if you want to read the documentation, just write help. I want help regarding pd.to_numeric. And here we have the documentation. So this particular function comes with a parameter error. Now error can be, or errors with the S can be ignore, raise or coerce. If raise, then invalid parsing will be raised as exception. Right now it is raise and you are getting an exception. If coerce, then invalid parsing will be set as nan. So wherever pd.toNumeric is not able to convert a particular value into numerical format, it will set that value as nan, nan. Now that is what we want, right? If I want that if this particular value is not getting converted into numeric, it should be converted to nan, right? Because a white space essentially mean nan, right? So this is what I want to do. What is the meaning of ignore? Then the invalid parsing will be return the input, which basically mean I am not going to consider that complete row. And that is, I do not want that to happen. So we'll use error is equal to coerce. And now you can see that I'm getting float 64, right? Let's preserve it back to the same column. And let's check the data types of various column now. And here you can see that we have three numerical columns. Tenure is in integer, monthly charges, total charges are in float, and everything looks good now, right? So this is a part of data cleaning that I was trying to explain to all of you. Now, once we are clear with this, once we are clear with how to make our data into correct data types, because once my data is in correct data type, then it will be quite easy for us to perform various analysis and plot various columns. Now let's try to understand, or let's start discussing about how to perform end-to-end data analysis. And for basically understanding the process of end-to-end data analysis, we'll be taking the example of the YouTube data. So I was able to download the data regarding YouTube uploads, the YouTube India uploads from the Kaggle website. And you guys can also find it out in Kaggle. If you just write Kaggle YouTube data India, it will return you, it will take you to a particular web page where you have the data regarding all the uploads that were made on the YouTube platform from the India region. So we are going to use that data, perform the analysis, and we will try to answer some hidden questions, or we will try to find out the answers of some questions from the data analysis that we will perform. So let's get started. Now let's start with the YouTube data analysis, and here we are going to perform the complete end-to-end data analysis. We will try to find out some interesting insights from the data, but before we can actually perform data analysis, we have to clean the data. So the complete process of data analysis will be divided into 3 steps. Number 1, to perform data cleaning and data understanding. Number 2 is to formulate the problem statement or the hypothesis. And number 3 is the analysis, where we will be performing data visualization, or we'll be trying to slice and dice the data to get our required answers. So let's start this. First of all, we will load the data, pd.read_csv, and I have already uploaded my data in this particular repository known as data.word. So let's upload it. So here's my data. Now let's first of all understand the data. We have video ID. This is a unique ID given to each video. So whenever you upload your video into YouTube, YouTube assigns a unique video ID, and that is what we have over here. Trending date. Now, whenever you upload your video, there is an upload date. So on the date on which you have uploaded the video, that is your upload date. And this is what we have, the published time. Published time is having the date and the time. I'll talk about how this time has been represented, but published time talks about the date and the time on which your video was published over the YouTube platform. Trending date is the date when your video came into the trending list. Now, those of you who are very familiar with YouTube platform, and I assume that all of you are very familiar because you are listening to me on the YouTube channel. So there is a trending list, and this trending list is specified, or it is different for each region. So let's say if you are listening to me from South India region, then the trending list would be different for the South India region, and the trending list will be different for the North India region. And specifically, if I talk about the region in the Bihar side or UP side, the trending list will be different, or in the side of Gujarat or Mumbai, it would be different, right? So trending date talks about the date on which your video listed on the trending list. Then we have the title of the video, the channel title, the category in which the video was loaded. We have tags. So while you upload the video, you have to provide some tags regarding your video so that the YouTube algorithm can understand what is all about, or maybe what is the content of the video. So tags are really useful for the algorithm to categorize your video into some category. And then we have views, likes, dislikes. Then we have comment count, thumbnail link, comment disabled. So when you uploaded your video, have you disabled the comment? So if it is true, that means comment were disabled. False means it was not. Rating disabled, again, is are you giving the option to your viewers to click on the like and dislike button? So if it is false, that basically means the particular viewer can click on the like and dislike button. If it is true, that basically means the person cannot do that because that has been disabled. Video error. So is there any error in the video, or the video has been removed? So you will get a true over here. Description of the video, the complete description section is presented over here. Now this is the data which we have been provided with. Now the very first thing that we will do is to understand whether the data has all the columns into correct data type or not. So let's quickly do df.dtypes. Now we have trending date in object. So the very first problem is the trending date column. The trending date column is in object. And the second problem is regarding, if I talk about publish time, this is also an object. So publish time is also in object. So these are the two problems that we have. If you look carefully for all other columns, for example, all these columns, comment disabled, rating disabled, video error, these all columns are having the content as true false. So they have been loaded as Boolean. If I talk about description, it is an object because it is a complete string. Then we have views, likes, dislike, comment count. These are all the integer values. Then we have the title, video ID. Since video ID is in alphanumeric, it has been loaded as object. So all other columns are in correct data type. We have only these two columns which are incorrect. Now what is the correct data type of trending date and publish time? Well, that is Pandas date time format. It should be loaded in date time format. Now how we can do this? So we have learned about pd.toNumeric and what is the objective of that function. So we have already learned about pd.to_numeric, and the objective of this function is to convert a object column into a numerical column, and this particular function is intelligent enough. So object column into numerical column, and this function is intelligent enough to recognize the correct data type of the numerical column based on the content of the column. So if the column is having floating values, then it will be converted to float 64. If it is an integer, then it will be converted to integer 64. There is one more function which is known as pd.to_datetime. Now the objective of this particular function is to convert the object column into the Pandas datetime format column. Pandas datetime format column. This is what this function will do. Let's try to utilize this function. We will first of all try to convert the trending date. So pd.to_datetime. I want to convert the trending date column, and let's run it. Now it is returning me error. It's saying month must be 1 to 12, 17, 14, 11, present at position 0. What's the problem? Let's go back to the data. Here, the trending date is 17, 14, 11. Now what is the meaning of 17? What is the meaning of 14? What is the meaning of 11? The function pd.toDateTime can convert a object column into a Pandas datetime column if the dates presented in the datetime column are in standard datetime format. Right now, this column trending date is having the date, but it is not in standard format, and that is the reason my pandas datetime function, the conversion function, is not able to understand what is the meaning behind 17, what is the meaning behind 14, what is the meaning behind 11. So we have to declare that while we are trying to convert this column trending date into the pandas datetime format, we have to also provide this function datetime with the declaration regarding what is the meaning of 17, what is the meaning of 14, what is the meaning of 11. Now if I ask you, all of you, to recognize this, then all of you can simply say 17 basically means year, right? 17 is year, because here also you can see 2017. So 17 is definitely my year. What is 14? Now 14 cannot be a month. A month can be between 1 to 12 only. So 14 is definitely my date. And what is 11? We are left with the month. So 11 is my month. Now we are able to understand that 17 is my year, 14 is my day, 11 is my month. I have to tell the same thing to this particular function, and then this function would be easily able to transform or typecast this column into pandas datetime format. Let's do it. So here we have an option known as format. Format is equal to, now how to declare the format? You guys can use this amazing website known as strftime.org, and this will help you with all the formats which we can use to declare or all the codes which we can use to declare the format in the p.toDatetime function. The very first component of my format is year, and year does not comes with the century. So here we do not have a century, we just have the year. So how we can declare it? For year without century, we have %y. Let's write it down over here. So %y. This is followed by a dot. So let's put a dot. Then we have 2-digit day. So 2-digit day, where is day? We have, here we have day. 2-digit day is represented as %d. So let's put %d over here. And then finally we have the month again in 2 digits. So 2-digit months, we have %m. Let's do that. %m, and let's run it. Now you can see that we are able to convert the column into datetime column. Let's preserve the values back to the same column. And now trending date column is our datetime column. Let's quickly cross check df.dtypes, and here we have datetime column. Now let's target publish time column. Publish time column right now consists of two components, the date and the time. Time is in very weird format. There is a Z. Now this represents the universal time format, UTC. So let's ask Google about UTC. What is UTC format? And the unit. So the unit of UTC format is the Z. So here we have UTC format, which is universal time coordinated universal time, and this particular universal time is having a unit of Z. Let me just quickly search where I can time zones. Okay, let's quickly just Google it directly. Unit of UTC time format or UTC time zone. So here you can see military name is Zulu Zulu is basically we are using the unit Z. I can just quickly go to, let's go to Google, and Google will help us with the correct answer. Unit of UTC time zone. Okay, so here I might be writing it wrong. So what is Z in UTC time? So the Z stands for 0 time zone, as it is offset by 0 from the coordinated universal time coordinate. It is basically, you can assume that it is like a reference point. The time zone using UTC is something denoted like this by the letter Z, a reference to the equivalent nautical time zone, which has been denoted by Z. So you guys can read about it, but the point that I'm trying to make right now is we have the date followed by the time, which is in the UTC time format. Let's try to convert this column into Pandas date time format. Now, since this column, or the values or the content of this column is in very clean format, so 2017-11-12, since the format of this object column is very clean and is standard, I do not have to make the declaration. So all I have to do is pd dot to underscore date time df and this column, and let's run it. Now you can see it has been converted with the time in UTC. Let's preserve it back to the same column. And now if I quickly check my date types, here you can see that trending date is in date time, published time is also in date time. If I look at my data, now here we can see that trending date is having the trending date in proper date time format. Published time is also having the date and time. But in the published time column, so as per the analysis right now which we are going to perform, I will not be doing anything with the time, or maybe I can put time in a different column, but right now I want to fetch the date from the publish time column. Now if your column, there is a very good function that comes with the Pandas date time format. Let me tell you that. So if a column and the data frame is in Pandas date time format, Pandas date time format, then we can use, so let's say my column is publish time. Now I know that this column is in Pandas date time format, right? We know that this column is in Pandas date time format. Now if I put this dt and dot, so this dt is basically a successor which can help you to perform extraction of various components of date and time. So helps in extracting various components of date and time. And after this I can write the name of the component which I want to extract. So let's say I want to extract only the date, so I can write date. If I want to extract time, I can write time. If I want to extract year, I can write year, similarly month, similarly day, similarly hour, minutes, seconds, and I can extract all the components as I want. Let's quickly test this in Python. So here we have the column df. I hope the publish time, yeah, publish time, that's publish time dot dt dot, let's say I want to extract date. Now here you can see this has extracted only the date. What if I want to extract time dot time? So here we have time. Let's say I want to extract seconds. Okay, second. So we do not need s, second. Let's say I want to extract only the year. So year, right? So this is how we can use the DT successor to perform extractions in a very easy manner, right? Let's create two columns now, one with the date and one with the time. So I'll create a column publish date, which will only have the date component from the publish time column. So let's copy this, put it over here, and I want date. Let's create one more column, which I will call as publish time, and this will have publish time dot time. Let's run it. Now if I look at the head, we now have two columns. One is trending date, publish time, which is having only time, and then we have a new column known as, so this is my new column, publish date. Now if I quickly look at the d types, df dot d types, we have trending date. Okay, we have trending date, which is in date time. We have publish time, which is in object, and we have publish date, which is also an object. Now there is one thing that we have missed. When we use this DT regressor, it returns the column, or it returns the series in the object format. So we have to again typecast. So in order to make the correction, I have to go back and reload the data. So let's reload it. So here we have the data. Let's run this command. Then let's run this command. Then over here, we will perform pd dot to underscore date time, and I'll pass this value. Similarly for this, pd dot to underscore date time, and we'll pass this particular value. Okay, so time we cannot convert into date time, so let's keep it as it is. Anyhow we are not going to use it. Now let's look at the output. So here we have the output, and let's look at the d types. Now we should have trending date in date time, publish date in date time. Now we are done taking care of the date time columns. We are done with data cleaning. Now we can start with the hypothesis formulation and data analysis. So let's do that. Now let's formulate the hypothesis, or maybe the problem statement. Here we are going to analyze two things. Number one, we are going to check the pattern behind those videos that were trending on the same day as they were uploaded. So pattern behind those videos that were trending on the same day of the upload. Second is the pattern behind the T-series YouTube data. So as you guys already know, T-series is the channel with highest number of subscribers in India and even in the world. So T-series analysis about how they upload the video, at what frequency, and at what maybe at what season they upload the video. So these are the two things that we are going to perform as of now. Let's start with the very first thing. Before we do that, let's look at the video with highest number of views. So in order to look at the video with highest number of views, I will just quickly do a sort. So df dot sort underscore values, and I want to sort my data on the views column. So df, now we do not need to write df, we'll just say views, and we can also say by is equal to views, and I want to do it in descending. So how is equal to, or ascending is equal to false. And here we have the result. The video with the highest number of views is this particular video, YouTube Rewind the Shape of 2017, and this video got these many views. But there is something which you guys should look very carefully. The same video is available over here also. YouTube Shape of Rewind the Shape of 2017. The same videos over here also. So this video has been in my presented in my data for 3 times. Why? What is the reason? Let's look at only a few columns to understand the reason why we are having the same video for multiple times. So I'm going to look at the video ID, df.columns. So let's look at the video ID, the trending date, the title, and then we are going to look at views, likes. So let's look at only views, and finally the published date, which I can put beside trending date. If I look at this data, and if I look at this data of for this video only, this particular video, let's filter the data for this video only. So df video ID is equal to this. So if I look only the data for this video, which is the video that is having highest number of views in my data, you can see that the data which is presented to us is a cumulative data. This video was published on 6th of December 2017. It was on the trending list for 7th, 8th, 9th, 10th, 11th and 12th. And you can see that the final row is having the final views on the final day of the video on the trending list. So there are 2 things that we can understand from this data. The way the data has been presented to us is, number 1, the number of times a video ID, the number of times we have the video ID in the data, it represents the number of days the video was on the trending list, right? This is the very first thing we can understand. Second thing is, the final row for each video, for each video ID, is the row with the final number of views, likes, counts and all other parameters These are the two things that we can understand after this particular analysis. How we can get rid of all these rows and how we can only get this particular row. So what you guys can also do, I'm just leaving this particular task for all of you. I'll just put it over here. Create a new column with each video ID and the count of maybe the number of days it was trending. So I can just give you a quick hint. If I do df video ID dot value underscore counts, I will get how many times a particular video is basically presented or is available in my data. Hashtag name question mark, these are the videos which does not have any video ID, so we will ignore this. But from here you can see that I'm having the count, or maybe the number of days this video ID was on the trending list. So if I ignore the first row and if I convert this into a data frame, pd dot, or let's do a quick reset index dot reset index. Now this is the data frame, or maybe this is a result that I can use to merge with this data frame, the main data frame, and I will eventually get one additional information regarding how many days the video was on the trending list. I'm leaving this task for all of you. What we are interested in doing is I want to remove all these rows and only get the last row for each video ID which has been duplicated. So what I want to do is preserve the last row for each video ID that has been duplicated. This is what we want to do. Before we do that, let's try to check if the data is having natural duplicates. What is natural duplicates or complete duplicate? So let's take one example. Let's say I'm having this data. Here I'm having video ID. Let's say this is the name of the video, the views, and the date. Let's say the video ID XX2156. Name is, let's say, T series. Views is, let's say, 1000. Date is 12/12/2023. If I'm getting the same row with the exact same details, now this is the example of completely duplicated row. This is the example of completely duplicated row. So first of all, I will check if we have completely duplicated rows, and if we have them, we will remove them. We will keep only one of them. If yes, keep one. Second is the particular problem that we have discussed. Out of all the rows for which the video ID has been duplicated, I'll keep the last row. And why last? Because the last row is having the cumulative details. Number of views, counts, comments, everything is cumulative in the last row. So these are the two things that we are going to do. Now the function that we are going to use is drop_duplicates. This is the function we are going to use. Now let's understand how we can use this function to tackle both the problems. So what we will do, we'll first remove complete duplicated row. complete duplicated rows. So df dot drop underscore. First of all, let's look at the help of this function. Let me just quickly explain you how this function looks like. Duplicates. So this is the function. Now this function takes input as, so here we have the parameters subset. Now if I want to look at the duplicates on a certain column, then I'll use the parameter subset. So if I just want to look at the duplicate on one column, let's say video ID, I'll put subset is equal to video ID. Then it will look for duplicates in the video ID column itself. As of now, my consideration is to look for all the columns where the complete row is a duplicate of another row. So subset will be all the columns. By default, it uses all the columns. So we do not have to declare it. Keep first, last, false. By default, it is first. So as of now, we are worrying about the complete duplicate row. So if I keep first or if I keep last, both are same. So we are not worried about this. In place is equal to true. In place is equal to false. So are you interested in removing the duplicates in the same data frame? Are you interested in performing the operation in the same data frame? You can keep in place is equal to true. Let's use it quickly to drop all the complete duplicated row. But are we having any complete duplicated row? Let's check. Df dot duplicated. Df dot duplicated. And I think we need to use sum also. Yes, we are having 4,263 rows which are exactly same of each other. So we will drop them. Df dot drop underscore duplicates. And I'll do this in place. So in place is equal to true. Now if I run it again, we should not be getting any answer. We should get 0. And we have 0. So we have tackled the complete duplicate row. Now the second problem. Out of all the cases in which video ID is duplicated, I want to keep the last row, right? So let's quickly do that. Df dot drop underscore duplicates subset is equal to the video ID column, and I want to keep the last. So keep is equal to the last row, and I will do it in place. So in place, you guys can preserve it in a new data frame also, but I am doing it in place. In place is equal to true. And now my data frame is free from all the problems. So if I just need to cross check, I'll just copy this code, put it over here, and I should get one row, the final row for this video. So I am having one row, and is this the final row? So the last trending date is 2017-12-12, and this particular result also, the last date is 2017-12-12. So the operation has been correctly applied. Now my data is free from duplicates. I'm having exactly one row for each video ID, which basically means now we can start the analysis. My data is now 100% clean. I would not say 100% clean. There might be some more data error and some more problems. But as of now, based on our hypothesis or our problem statement, my data is clean. So let's now start the analysis. So now the particular problem statement that we were trying to solve was to analyze the pattern behind those videos that were trending on the same day as they were published. Now, how to find out those videos that were trending on the same day as they were published? Now this is the question. The easiest answer is wherever the published date and trending date are same, we will call that particular day, or we will call that particular video as the same day published video. So wherever the trending date is equal to published date, that is the same day trending video. Now here we have done a small error, that before we have done this particular operation, we should not have done it, because let's say a video was published on 2017 12/12 and it trended only for 1 day, or maybe let's say 2 days. Then in that case we haven't preserved the first row, we have only preserved the last row, so that would be a problem. Let's do one thing, let's go one step back. We will do this operation once we are done with this analysis, and then we will do this operation for the T-series data one. So what we are going to do, we are going to again run the complete code till that point. Okay, let's go back over here. This is my, let's run it. Then let's run this one, then this one, then this one. Finally we will run this one, and now we will not run this one, this command we will not run. We will come back to this point, so let's just put them as comment right now. We'll come back to this point. Let's now perform this operation. So I'm going to filter my data wherever the published date is equal to the trending date. Now this is the particular data, or this is a particular data which we are interested in. So wherever published date and trending date are same. So here you can see the trending date is 2017 11/16, and here also the published date is 2017 11/16, right? Let's preserve this in a variable known as same_day. So this is my new data frame with all the videos that were trending on the same day. So same_day dot head. Now we will do a quick count, like how many channels are having the same day trending video. So the same day channel title and dot value underscore counts, and here we have these 4 channels with highest number of videos that were trending on the same day as it was published. Let's look at top 20 only, and these are the results for top 20. Adda 247, Wi-Fi Study, Mahindra Guru, Steady IQ Education. These 4 channels are having highest number of same day trending video, which basically means as soon as they published the video, it became trending. And Adda 247 is having 48 such videos. What is the reason behind it? Let's quickly go to their YouTube channel and let's check it out. So first of all, we will look at Adda 247. Let's open it. Then we have Wi-Fi Study. Wi-Fi Study. Let's open it. Then we have Mahindra Guru. Let's open this. And then we have Steady IQ Education. Let's open this one also. Now if I look at Adda 247, you can see that they have some scheduled videos, scheduled live streams. These are the previous live streams and these are upcoming. So this is at 2 p.m. today. This is at 3:30 p.m. today itself. This is 5 p.m. today, 6 p.m. today, 7 p.m. today, 8 p.m. today, and then till 8 p.m. they have the upcoming live streams for today. Then for tomorrow, they have a live stream tomorrow, and so on. So they have a series of scheduled live streams. What about Wi-Fi study? For Wi-Fi study, again, these are scheduled for 9/1/23. Basically means this is for I think the next month at 7 a.m. and these are all other streamed videos that streamed previously. Do we have upcoming? So here is one upcoming only, and I think they don't have any upcoming as of now. Okay, they don't have any upcoming. Let's look at Mahindra. So Mahindra is 2 live videos are currently running. They have upcoming live streams. Again, the same pattern for the same day, 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 9 p.m., 10 p.m. and so on. Various live streams, series of live streams scheduled for today. For Study IQ Education or Study IQ IAS, again upcoming live streams at 5:20 and 7 p.m. And then there are past live streams which happened 1 hour ago, 4 hour ago, 18 hour ago, and series of live streams. Now, one common pattern which you can find out after looking at all these YouTube channels is they are doing a very frequent live streams. Now, what happens in live stream? Let's understand the strategy. So if I consider this plot, which is having, let's say this is time and this is views, then when you do a live stream, you get significant number of views at a very small time interval, and then it becomes constant like this. So this is the graph that you will get if you do a live stream, and this is the time, this is the portion. So this particular portion defines the duration of live stream. Duration of live stream. But if you upload a video, then something like this happens. You get a very linear increase in the viewership, and then it becomes steady, like maybe the video becomes trending, and then it becomes steady like this. So this is a kind of graph you get when you upload a video. Now this is the advantage of live stream advantage. So when you do a live stream, you get a significant amount of viewership in a very short duration, and this makes the algorithm put your video in the trending list. And that is the reason you might have seen YouTubers like Carrie Minati are doing a good number of live streams, because when you do a live stream, you are basically getting very good viewership in a very short duration. So this essentially helps the algorithm to understand that, okay, your video is doing very good. So the algorithm puts your video in the trending list. So now I hope you guys are clear with the very first question, why a particular, or maybe why these 4 channels, the top 4 channels that we found out, are having so many same day trending videos. So the day they uploaded their video, or maybe the day they did their live stream, the same day their video became trending. Now let's understand, or maybe let's solve the next question about how T-Series is uploading their video. So T-Series analysis. Before we start the T-Series analysis, we will quickly perform the operation which we have not done. So I'll preserve the last row of each video, and then we'll filter the data for T-Series. So T-Series is equal to df channel title is equal to T-Series. Now let's check how many rows we have in T-Series. So we have 62 rows, which basically means T-Series has only posted 62 videos. Let's look at their head. Now what we are going to do, we are going to check the monthly upload of T-Series. So in total, T-Series has only uploaded 62 videos. But what was the frequency month-wise? So from the published time column, we will extract, from the published date column, we will extract the month. So T-Series month is equal to T-Series published date and .dt month. I hope you guys now know why I have used dt.month. And let's now do a quick value count. T-Series month dot value underscore counts. Now in the month of February, it has posted 11 videos. March it has posted 10, December it has posted 9, January it has posted 9, and for few months the video has not been posted. So let's write down the observation. For month February, 11 videos are posted, March 10 videos, and if I look at January, February, March, April, or maybe from December, January, February and March, you can see that it has posted around 39 videos, right? So 10, 20, 30 and 39 videos, which is around, let's assume 40, and total videos are 62. So you can see that a good amount of videos were only uploaded on in the month of December, January, February and March. Now why? The very first reason that you guys need to understand is T-Series is a entertainment channel, which basically means it uploads musical videos, it uploads maybe the content related to Bollywood movies and so many songs, right? So these 4 months in India are filled with, or maybe it is heavily loaded with all the festivals and the wedding season. So guys, right now what I am doing is I'm trying to correlate the reality with the result that I've obtained in my data to make sense out of the data, to make some inference. So the inference that I'm able to derive, and please remember, my point of view, my reference on my inference can be very much different from yours, because I'm using some logic, you guys can use some logic. So it is completely fine if we both are different, but the point that we both are trying to solve is to understand why this thing happened. In the same day trending video, the same thing we did. To find the answer, we looked at their YouTube channel and then we were able to find out something interesting. Right now, why they have uploaded so many videos on just these 4 months? We are trying to correlate the data, the result with the reality. Now the reality says in India, because this is Indian data, so in India, your month December, January, February and March, these are heavily loaded with very good amount of festivals. So we have festivals, we have the Valentine Day, we have the wedding season, and due to all these I would say due to all these happening days in all these 4 months, YouTube has, or T-Series has uploaded so many videos, because T-Series is basically the entertainment channel. I can prove this. Let's look at the data only for month 2. So T-Series month is equal to 2. If I look at the data only for month 2, we should be able to get some romantic song, because this is a month of Valentine's Day, right? So we have Binte Dil, we have some song from Hate Story 4. You guys already know what is Hate Story 4 is all about. We have the song Sanu Ikbal Chan. We then have Nit Khair Manga, again a romantic song. So you can see that in this month they have organized the videos in such a way that it basically correlates with the sentiments of the Indians and the particular season, so that people are trying to listen the same songs or trying to watch the same kind of video in which they are in the mood, the current mood. If I look at 12th, the December month, and now all of you guys know that in the month of December, India gets so many weddings, right? So there should be a song which should be a party song, right? So here we have a mixtape, Punjabi mixtape. Now since it is party, Punjabi mixtape is getting released. Again Punjabi mixtape, again a Punjabi mixtape. Some DJ song, Guru Randhawa Lahori. If you go back to year 2017, Lahori song was a very famous song at that time. Yo-Yo Honey Singh Dil Chori, again a very good party song. So you can see 2 party songs and 2 Punjabi mixtape. They have strategized their uploads in such a way that it matches the requirement and sentiments of the Indian, right? If I look at the month of March, again, what is special about March? It's Holi. Again, we should get a dance song, because when we play Holi, we listen to some party songs. So here we have Mundia song. Again, it is an item song from Bagi 2, Mundia. Then we have Patola. Then we have, so here we can see we have 2 party songs, Mundia and Patola. So the point that I'm trying to make over here is, we have seen everything, is the reason T-Series is posting so many videos on these specific months is because their genre is entertainment, and these are the months in which India or Indians are in the entertainment mood, are in the party mood. And the reason is, number 1, we get so many festivals. So we have Christmas also, we have holidays also, students get the winter vacations. Then we have New Year, we have Valentine's Days, we have so many weddings happening. Then we have Holi also. So all these things are happening in these 4 months, and that is the reason T-Series has tried uploading most of their videos in these 4 months. If I quickly look at the percentage, then we'll be able to see something very interesting. So how we can look at the percentage? I'll just normalize this. Normalize is equal to true, and I'll multiply it with 100. And here we have the result. So 17.74 plus 16.12 plus 14.5, 14.5 plus 14.5. So the total is 62.82. So 62% videos they have uploaded in these 4 months and rest in all other months. Now if you carefully observe, for January, February, March, and then April, May and June, they have the video uploads. July, August, September and October, they do not have a video. Now there are multiple reasons around it. One particular reason which I can think of is the floods. You can see that in India, due to the season of rainy days in July, August, September, India gets a lot of floods in various regions, right? Due to which T-Series know that this is not the time of entertainment, and they know that even if they upload a video, it is not going to work as expected. It is not going to reach as many people as they want, because the India is suffering from some kind of problem. So they stick to not uploading a video, making sure that their efforts are not going in vain. And that is the great strategy used by T-Series to make sure that they are the most popular entertainment channel in India and most subscribed channel the worldwide. So that was all about this particular video. I hope you guys understood the process of how we performed end-to-end data analysis. We talked a lot about how to perform data cleaning, and then we performed the data analysis process in 3 steps. Number 1, it was data cleaning and data understanding, followed by problem statement formulation and hypothesis formulation, and then the third was data analysis. Now you guys can extend this to the T-Series Bhakti Sagar channel also, and you guys can extend it to any depth you want. So I have just shown you a very limited analysis, but if I keep on doing this thing, it would take me around 8 to 9 hours to completely analyze this data. But I leave this to all of you. I will provide this data to all of you in the description section. You can utilize this, you can play with this, perform your analysis, and don't forget to comment your analysis on the chat section, because I read all the comments. So hope to see you guys in the next video. I hope this module was informative and really useful for all of you. If you like this video, give it a big thumbs up, share it with your friends, and don't forget to subscribe to our Scalers YouTube channel.